Bismillahirrahmanirrahim. Equilibrium constant expressions involving partial pressure, number of moles, and mole fraction. We consider a general reversible reaction in which reactants A and B react to form product C and D. Capital A, B, C, and D are representing reactants and product, and small alphabet small a, small b, small c, and small d are representing the numbers used to balance the equation. At first, we have to write the equilibrium constant expression when concentration is expressed in terms of the molarity. If concentration is expressed in terms of the molarity, we will write concentration of the products over concentration of reactants, and number of moles used to balance the equation will be represented in the form of the exponents in the equilibrium constant expression. If we express the same equilibrium constant expression in terms of the partial pressure, we will write the same expression as we had written in Kc expression. Instead of C, we will represent P. P will represent partial pressure. So Kp is the equilibrium constant expression when concentration is expressed in terms of the partial pressure. We will write the same expression as for the Kc, but instead of writing a square bracket, we will write capital P. Capital B will represent the partial pressure of the reactants or the products. Instead of writing square bracket represents concentration expressed in terms of mole per dm cube. We will represent capital P. So at first we will write concentration of the products. Products are C and D, and concentration of reactants. Reactants are A and B. And the numbers used to balance the equation will be represented in the form of the exponents C, D, A, and B. Similarly, if we want to write the equilibrium constant expression when concentration is expressed in terms of the mole fraction is represented by capital X. So instead of writing P, we will represent it with the X, and instead of writing P, we will write mole fraction. So we will write mole fraction of the components C, D, and similarly A and B. And the numbers used to balance the equation will be represented in the form of the exponent C, D, and AB. So we'll write the same expression as for the partial pressure, but instead of writing partial pressure, we will represent it with the capital X that represents mole fraction. So mole fraction is in fact moles of the component divided by the total number of the mole. Next, we write a relationship relating these three equilibrium constant expression, mean relationship between Kp with Kc, Kx, and Kn. These are three relations. Kp is equal to Kc RT delta and K equivalent. R is ideal gas constant, T is temperature. Similarly, Kp, if we relate Kp with Kn, Kp is equal to Knp over N. N over there stands for the total number of moles of the reactants and products at equilibrium. And if we relate Kp with Kx, so Kp is equal to Kxp into delta N. Delta N is equal to the number of moles of the products minus number of moles of the reactants. Such as if we have this equation, in this equation there are 2 moles of the product and 4 moles of the reactant, 1 mole of the nitrogen and 3 moles of the hydrogen. If we want to find delta N will be equal to 2 minus 4 is equal to minus 2. Delta N will vary from equation to equation. According to the equation, we will find delta N by subtracting number of moles of the products from number of moles of the reactants.